Hello everyone, Dennis here. This is GCE O Level Mathematics, Lecture 23, Simple Algebraic Fractions. In this lecture, we are going to learn to express an algebraic fraction in its simplest form. Perform the 4 operations on algebraic fractions, change the subject of formula, and find the value of an unknown quantity in a given formula. Simplifying simple algebraic fractions. When a number is in the form of a over b, where a and b are integers and b is not equal to 0, it is called fraction. Examples are 3 over 5, 19 over 13, and negative 2 over 3. As you can see in these 3 examples, fraction can be just a normal fraction. The second fraction is an improper fraction, and it can be also a negative fraction. So as long as it is in the form of a over b, it is called fraction. When an algebraic expression is in the form of a over b, where a and b are expressions involving 3 basic operations of plus, minus, and multiply, and b is not equal to 0, it is called algebraic fraction. Here are a few examples: x, y over z, p plus q over p minus q, and 2x squared plus 3x plus 1 over 4x minus 5. Since the denominator of a fraction cannot be 0 because division by 0 is not valid, then from the above examples, let's look at the first fraction. The z cannot be equal to 0. For the second fraction, p minus q, p cannot be equals to q. And for the third fraction, the denominator is 4x minus 5, hence x is not equals 5 over 4. To simplify an algebraic fraction, we will apply the following concept. If c is not equal to 0 and c over c equals 1, then a times c over b times c equals a over b times c over c, which is a over b. On the other hand, a over c over b over c can be written as a divided by c over b divided by c, and also a over b divided by c over c. When we simplify, we'll get a over b, where b is not equal to 0 for both cases. Example 1. Simplify the following expressions in the simplest form. A. 15xy cubed over 45x squared y squared. B. 12p cubed q minus 20p squared q cubed over 16pq squared. So here's the solution. For A, 15xy cubed over 45x squared y squared, the numerator and the denominator, their LCM is 15xy squared. So we can write the fraction as 15xy squared times y over 15xy squared times 3x. Then from here, we can cancel out the 15xy squared. So the answer will be y over 3x. Alternatively, we can apply indices law, which we have learned in the previous lesson. So this is how we can do it. For the fraction given, the number divide with the number, and we can apply indices law when it comes to fraction where the unknowns we minus the power when it is division. So the expression becomes 15 over 45 times x to the power 1 minus 2 y to the power 3 minus 2. So we'll get 1 over 3 times x to the power negative 1 y to the power 1. Want to put the answer as positive indices, hence the answer will be y over 3x. For B, 12p cubed q minus 20p squared q cubed over 16pq squared. So what we have to do is we factorize the numerator. So for this case, the common factor is 4pq, then multiply by 3p squared minus 5q squared. At the denominator, we can write as 4pq times 4q. Then we cancel out the 4pq. The answer will be 3p squared minus 5q squared over 4q. Try yourself 1. Simplify the following expressions in the simplest form. A. 54 c squared d over 63 cd squared. B. 35 g to the power 5 h cubed over 14 g cubed h squared minus 7g h squared. You can pause the video and try to solve it yourself. So here's the solution. For A, 54c squared d over 63c d squared can be written as 9cd times 6c over 9cd times 7d. Then we cancel the 9cd. The answer will be 6c over 7d. Or another alternative method where we apply the indices laws. So 54c squared d over 63c d squared, the number divided by the number, and for the unknowns, when we comes to the division, the power will minus. So for this case is c to the power 2 minus 1, d to the power 1 minus 2. Simplify, we get 6 over 7 times c to the power 1, d to the power negative 1. They want to leave the answer as the positive indices. So the final answer will be 6c over 7d. For B, 35g to the power 5h cubed over 14g cubed h squared minus 7gh squared. So now we can do is factorize the denominator. We'll have 7gh squared times 2g squared minus 1. For the numerator, we can write as 7gh squared times with 5g to the power 4h. Then we cancel out with the 7gh squared. So the answer will be 5g to the power 4h over 2g squared minus 1. Now let's look at example 2 with more complicated algebraic fraction. So simplifying the following expressions in the simplest form. A. 4kx minus 8ky plus 3rx minus 6ry over 12kx plus 8ky plus 9rx plus 6ry. And B. 6x squared minus 17xy plus 12y squared over 9y squared minus 4x squared. So here's the solution. For A, we need to factorize both the numerator and denominator using the grouping law. So for the numerator, when you factorize, we will have 4k times x minus 2y plus 3r times x minus 2y over, for the denominator, we will have 4k bracket 3x plus 2y plus 3r bracket 3x plus 2y. And from here, we can see that at the numerator, the common factor is x minus 2y, and the common factor for the denominator is 3x plus 2y. So we can factorize these common factors. We'll have x minus 2y times 4k plus 3r over 3x plus 2y times 4k plus 3r. And from here, we can cancel out the 4k plus 3r, And the answer is x minus 2y over 3x plus 2y. For b, we'll have to factorize both the numerator and the denominator. So we have learned factorization of quadratic expressions. So let's factorize the numerator. So there are 4 methods we can use to factorize as we have learned in the previous lesson. So from here, I would like to use the double bracket method because we will factorize it easier and faster. So what I have to do is I will write down 2 brackets, then 2x times 3x, I'll get 6x squared, and minus 3y times minus 4y, I'll get positive 12y squared. So now 3x times negative 3y plus 2x times negative 4y, which is negative 9xy minus 8xy, we'll get negative 17xy, which is the same as the middle term. Hence, this is the correct factorization. And for the denominator, it is in the form of a squared minus b squared, which is we can apply the special product of factorization. So from here, it becomes 3y plus 2x times 3y minus 2x. So from here, we can see that 2x minus 3y and 3y minus 2x, they are the mirror. So we can write here, right, at the bottom, the first bracket 3y plus 2x, usually we write in the alphabetical order. So a plus b equals b plus a, hence we can write as 2x plus 3y. And from the mirror, we can write, we know that a minus b equals to negative b minus a. So what we can do is, for the numerator, everything is the same. We just write down as 2x minus 3y times 3x minus 4y. And from the denominator, I'll put a negative sign in front. And then the second bracket, I write as 2x minus 3y. So after that, from here, we can cancel out the 2x minus 3y. So it becomes negative 3x minus 4y over 2x plus 3y. And this is reversible, where negative b minus a can be written as a minus b. So we can leave our answer as a positive fraction by changing it to become 4y minus 3x over 2x plus 3y. Now it's your turn to try this example yourself. Simplify the following expressions in a simplest form. A, 20mx minus 45my minus 28nx plus 63ny over 15mx plus 10my minus 21nx minus 14ny. For b, 15x squared minus 11xy minus 14y squared over 49y squared minus 25x squared. So here's the solution for a. We can again factorize both numerator and denominator using the grouping law. So it becomes 5m times 4x minus 9y minus 7n times 4x minus 9y for the numerator. Similarly, for the denominator, it becomes 5m times 3x plus 2y minus 7n times 3x plus 2y. And from here, the numerator has the common factor of 4x minus 9y, and the common factor for the denominator, we have 3x plus 2y. So if factorize these two common factors for both numerator and denominator, we will have 4x minus 9y times 5m minus 7n over 3x plus 2y times 5m minus 7n. Then we can cancel out the 5m minus 7n, and the answer will be 4x minus 9y over 3x plus 2y. For b, we can factorize these quadratic expressions one by one. For the numerator, so I will apply the double bracket methods again. So I'll write down the double brackets first, then 3x times 5x equals 15x squared, positive 2y times negative 7y equals negative 14y squared. And when we expand these brackets, So 5x times 2y plus 3x times negative 7y, which is 10xy minus 21xy, and the value is negative 11xy, which is same as the middle term. Hence, this factorization is correct. And for the denominator, it is in the form of a squared minus b squared. Hence, when we factorize, we'll get 7y plus 5x times 7y minus 5x. So we can see that 5x minus 7y and 7y minus 5x, they are mirror. So we can write this whole expression as the denominator, it is 5x plus 7y. The numerator is the same, 3x plus 2y times 5x minus 7y. So the second bracket at the denominator, first I'll put a negative sign in front and change the second bracket as 5x minus 7y. So from here, I can cancel out the 5x minus 7y. The answer becomes negative 3x plus 2y over 5x plus 7y. Okay, so for this example, I cannot make the whole thing to be positive fractions. So this will be the final answer. Now let's discuss multiplication and division of algebraic fractions. In arithmetic, we perform the operations of multiplication and division of two fractions as follow. So the first example A, it is the multiplication example. So 2 over 3 times 5 over 7. What we have to do is we can just multiply the numerator with the numerator and the denominator with the denominator. So for this case, 2 times 5 over 3 times 7, and the answer is 10 over 21. So for B, for the division case, we use the same fraction as A, but we change the multiplication operation to division operation. So for this case, what we have to do is we have to change the division sign to multiplication sign, and we change the fraction to its reciprocal. So what we get is 2 over 3 times 7 over 5. Then just numerator multiply with the numerator, which is 2 times 7, over the denominator multiply with the denominator. So for this case is 3 times 5, and the answer will be 14 over 15. So similarly in algebra, we'll perform the same operations of multiplication and division of two algebraic fractions as follow. So for A over B times C over D. So again, numerator multiply with the numerator, so A times C, and denominator multiply with the denominator, so over B times D. Okay, so for B, is we come to the division A over B divided by C over D. We apply the same concept where we change the division to multiplication and the fraction to its reciprocal. Hence, it will be A over B times D over C. Then from here, numerator multiply with the numerator and denominator multiply with the denominator. So it will be A times D over B times C. Alright, now let's see example 3. Simplify the following expressions in the simplest form. A, 5a over 4b times 6b over 7a b squared. B, 3pq cubed over 8r cubed s squared times 4rs over 9p squared q. And C, 12m squared plus 7mn minus 10n squared over 12m plus 15n times 6m minus 4n over 9m squared minus 4n squared. So here's the solution. For A, 5a over 4b times 6b over 7ab squared. So we can multiply the numerator with the numerator, we'll get 30ab, and the denominator with the denominator. So we will have 28ab cubed. Then from here, the number divided with the number and the letters or the unknowns is with the unknowns. So 30 over 28 times ab over ab cubed. When simplify, 30 over 28 we'll get 15 over 14. While for the the unknowns part. So we can cancel out the a, and for the b over b cubed, simplify, we'll get 1 over b squared. Hence, the answer will be 15 over 14 b squared. For b, 3p cubed pq cubed over 8r cubed s squared times 4rs over 9p squared q. So again, the numerator multiply with the numerator and the denominator multiply with the denominator. So we'll get 12pq cubed rs over 72 p squared q r cubed s squared. So then from here, the number divided with the number and the unknowns is with the unknowns. So 12 over 72 times pq cubed rs over p squared q r cubed s squared. That will simplify the number, we'll get 1 over 6, then multiply with the letters. So what we can do is, the p divided by p squared, we'll get p. And for the q cubed divided by q, we'll get q squared. For the r over r cubed, we'll get r squared at the denominator. And finally, s over s squared, we'll have the s at the denominator. And we combine these two fractions together, the final answer will be q squared over 6pr squared s. Next, for c, 12m squared plus 7mn minus 10n squared over 12m plus 50n times 6m minus 4n over 9m squared minus 4n squared. So by just looking at this example, do you have any idea how to simplify? So let's do it. For the first fraction in the numerator, 12m squared plus 7mn minus 10n squared, let's use double bracket to factorize it. So first write down two brackets here, and 3m times 4m will get 12m squared. Negative 2n times positive 5n will get 10n squared. And then negative 2n times 4m times plus 3m times 5n will get 7mn. After that, at the denominator, the common factor for 12m plus 50n will be 3. So I factorize the 3, and then bracket, it becomes 4m plus 5n. Then multiply, let's look at the second fraction. At the numerator, the common factor is 2. So we take out the 2 and left with, then bracket 3m minus 2n. For the denominator, as you can see from here, it is in the form of a squared minus b squared. So we factorize, it becomes 3m plus 2n times 3m minus 2n. And from here, you can see that we can cancel out the 4m plus 5. So similarly, we also can cancel out the 3m minus 2n. Then we combine them together. So 2 times 3m minus 2n over 3 times 3m plus 2n. So we cannot factorize or simplify further. This will be our final answer. Now it's your turn to try this example yourself. Simplify the following expressions in the simplest form. A, 7s over 10t times 5u over 7s. B, 8c squared d over 7pq times 14p to the power 4q cubed over 2c d cubed. C, 25a squared minus 16b squared over 10a minus 8b times 5a squared minus 4ab over 5a plus 4b. You can pause the video and try to do it yourself. Okay, here's the solution for A, 7s over 10t times 5u over 7s. we can just multiply the numerator with the numerator and the denominator with the denominator. We'll get 35 SU over 70 ST. Then we break it out, the number divided by the number and the unknowns, put them together. We have 35 over 70 times SU over ST. So S cancel with the S. 35 over 70 is 1 over 2, then times with U over T. Combine them together, the answer becomes U over 2T. For B, 8C squared D over 7P cubed times 14P to the power 4 Q cubed over 2CD cubed. So we will put the numbers together. 8 times 14 will get 112. 7 times 2 will get 14. Then the unknowns put together, we have C squared dP to the power 4 Q cubed over CD cubed P cubed. So we simplify the numbers, we'll have 8. Then multiply with the unknowns here. When we simplify everything, we will have C P cubed Q squared over D squared. Alright, then group them together. We'll have 8CP cubed over 8CP cubed Q squared over D squared. And for C, 25A squared minus 16B squared over 10A minus 8B times 5A squared minus 4AB over 5A plus 4B. So we can factorize each one by one. For the first fraction, the numerator, it is in the form of A squared minus B squared, so it becomes 5A plus 4B times 5A minus 4B. And the denominator, the common factor is 2, so it becomes 2 times 5A minus 4B. So this one I'm talking about. And then multiply with the second fraction, the numerator here, common factor is A. So take out the A, we have 5A minus 4B. And then this is just write down 5A plus 4B. Then from here, we can cancel out the 5A minus 4B and 5A plus 4B. So the answer will be A times 5A minus 4B over 2. Next, we will see example 4, which is the division of algebraic fractions example. So simplify the following expressions in the simplest form. For A, 7x over 4y divided by 21y over 20x. B, 5ab squared over 42c to the power 4 d cubed divided by 15a cubed b over 14c cubed d to the power 5. And C, m squared minus 4mn plus 3n squared over m squared plus mn minus 2n squared divided by m squared minus 2mn minus 15n squared over m squared minus 9n squared. So here's the solution. For A, 7x over 4y divided by 21y over 20x. So what we have to do in the very first step is we change the division sign to multiplication sign and change the second fraction to its reciprocal. So it becomes 7x over 4y, then times with 20x over 21y, because 20x over 21y is the reciprocal for 21y over 20x. So after that, from here, 20 divided by 4, we'll get 5. 21 divided by 7, we'll get 3. Then we combine these two fractions together, we'll get 5x squared over 3y squared. For B, so this is the fraction or the algebraic fraction given. So we change the division sign to multiplication sign and the second fraction to its reciprocal. So we remain the same fraction for the first fraction. So 5ab squared over 42c to the power 4 d cubed, then multiply with 14c cubed d to the power 5 over 15a cubed b. Okay, so from here it looks like a bit complicated, so we have to do it slowly, one by one. So we group the numbers together first. So 5 times 14 over 42 times 15, then multiply by the unknowns, we put them together. So it will be ab squared times c cubed d to the power 5 over c to the power 4 d cubed times a cubed b. Okay, so these two comes from the first fraction, these two come from the second fraction here. Then we simplify the number here, we'll get 119. Okay, and from this second fraction here, right? A divided by A cubed. So we'll get A to the power 1 minus 3. Okay, then B squared divided by B. So power is 2 minus 1 here. And then C cubed divided by C4 is C3 power minus 4. D5 divided by D cubed here. So 5 minus 3. So this is the answer. We get 119 times A to the power negative 2, B, C to the power negative 1, and D squared. And we group them together. We want to make the indices to be positive. The answer will become BD squared over 9A squared C. Okay, so now we move on to C. It's very long here. Okay, so what we have to do again in the very first step is we will change this division to multiplication and this fraction to be reciprocal. And we can actually factorize this first fraction first. Okay, so let's factorize m squared minus 4mn plus 3n squared using the double bracket method. So write out the two brackets here. M squared, right, is m times m, we get m squared. 3n squared is negative n multiplied with negative 3n. Okay, I put a negative sign here because I see that the middle term is negative. Then we can check again. Negative n times m plus m times negative 3n, we'll get negative 4mn. Okay, so we'll again factorize this quadratic expression here, m squared plus mn minus 2n squared. So write out the two brackets here. So m times m, I'll get m squared. Then negative n times positive 2n, I'll get negative 2n squared. Then double check, negative n times m plus m times positive 2n, we'll get positive mn. Okay, then move on to the second fraction here. Divide, change to multiplication. This fraction change to the reciprocal. So this is what we get. So the next step, we can start to simplify. Right, look at the first fraction here. We can cancel the m minus n. So only left with this whole thing, right, which is m minus 3n over m plus 2n. Then multiply by, we'll start to factorize this fraction. Okay, m squared minus 9n squared. So this is a squared minus b squared form. It becomes m plus 3n times m minus 3n. Then for this whole thing, right, we factorize m squared minus 2mn minus 15n squared. So again, use the double bracket method. So m times m and negative 5n times positive 3n. We get negative 15n squared. And double check, negative 5n times m plus m times 3n, we'll get negative 2mn. Okay, now the next step, cancel 3m plus 3n with m plus 3n. So only left with the m minus 3n over m minus 5n. They combine these two fractions together, m minus 3n, we'll get m minus 3n squared here, right, and the bottom m plus 2n times m minus 5n. So this is our final answer. Now it's your turn to try this example yourself. Simplify the following expressions in the simplest form. For A, 8cd over 9b divided by 18a over 27d. B, 5xy to the power 5 over 4a cubed b squared divided by 14x to the power 4 y cubed over 2ab cubed. And C, a squared minus 8a plus 15 over 4a squared minus 49 divided by a minus 3 over 2a plus 7. You can pause the video and try to do it yourself. Okay, so here's the solution for A. 8cd over 9b divided by 18a over 27d. So first, we have to change the division sign to multiplication sign and the second fraction to its reciprocal. So it becomes 8cd over 9b times 27d over 18a. After that, the number times with the numbers and the unknowns, put them together. So we have 8 times 27 over 9 times 18 times cd times d over b times a. So we simplify the numbers, we'll get 4 over 3. And for the unknowns, we'll have cd squared over ab. So we put these two fractions together, we'll have 4 cd squared over 3ab. For b, So this is the expression given. So the very first step again is to change the division sign to multiplication sign and the second fraction to the reciprocal. So this is what we get. After that, the next step is the numbers multiplied with the numbers. The unknowns, we put them together. So this is what we get here. Then next step, when we simplify the number, this is what we get, 5 over 28. And for the unknowns, we have to do it slowly one by one. So we start with the a first, right? So this a power 1 divided by a cubed, so 1 minus 3. We have this one. So for b cubed divided by b squared, so apply the indices law, is 3 minus 2, the power. Then move on to the x, right? X power 1 divided by x power 4, so it's 1 minus 4, the power. For the y power 5 divided by y cubed, right? So it's 5 minus 3. Then we calculate the powers here. This is what we get. And we have to leave our answer as positive indices. So we combine these two together. We'll have 5by squared over 28a squared x cubed. So this is our answer for B. Then move on to C. So this is the expression given. Alright, so we can factorize this whole thing. And this one. After that, we change this division to multiplication sign. Then change this to reciprocal. So this is what we get. I hope you can get this answer. Okay, then from here, we can see that we can cancel the a minus 3 with a minus 3 here. Similarly, 2a plus 7 cancel with 2a plus 7 here. So the answer will be a minus 5 over 2a minus 7. So this is the answer for C. Now let's move on to discuss about addition and subtraction of algebraic fractions. So in arithmetic, we perform the operations of addition and subtraction of two fractions as follow. So the first example, the addition. So 1 over 2 plus 2 over 5. Look at the denominator 2 and 5. The LCM of 2 and 5 is 10. So we can write it as the 2 multiplied with 5. And the numerator is 1 times 5. Then plus with, for the second fraction, 5 times 2, which we get 10. So the numerator is 2 times 2. Okay, so this is what we get, 5 over 10 plus 4 over 10. And we can see that we have the same denominator here. Hence, we can add these two fractions together becomes 9 over 10. So similarly, if you want to perform the subtraction, we have to make them to have the common denominator first. So for this case, we multiply the denominator, so 2 times 5. So from the numerator, it becomes 1 times 5, then minus 2 times 2. And which we get 5 minus 4 over 10, hence the answer is 1 over 10. So the idea is, we have to make sure that both fractions have the common denominator first before we can perform addition or subtraction. Alright, so must have the same denominator. This is the key point. However, as you can see from here, right, we can just multiply the denominator together, so we can get them to have the common denominator. However, the denominator do not have to be have to multiply together every time to get the LCM. So here is some two examples which is not the case, right? We have 1 over 4 plus 3 over 14. So the LCM for 4 and 14 is 28. So we don't multiply these two denominator together, but what we can do is we just change the 4 to 28, which is 4 times 7, we get 28. So for the numerator also 1 times 7. So we go to the second fraction here. So it is 14 times 2, we get 28. So the numerator is 3 times 2. Then we calculate separately. We will get 7 over 28 plus 6 over 28. Now we have the same denominator for both fractions. Now we can perform the addition. 7 plus 6 becomes 13, then over 28. Same case for the subtraction. So the idea is the same thing. We have to make them to a common denominator. So over 28. So 1 times 7 minus 3 times 2, which is 7 minus 6 over 28. So we have the common denominator as 28. Hence the answer is 1 over 28. Alright, when come to algebra, we apply the similar concept. In algebra, there are two types of algebraic fractions. The first one is the denominators with constants only. So here's an example, a simple example here, x plus 5 over 3 plus 2x minus 9 over 7. So from here, the LCM of 3 and 7 is 21. So all we have to do is just change them to the denominator of 21. So the first fraction, 3 times 7, and the numerator will be x plus 5 times 7. Then plus with the fraction, so 7 multiplied with 3 will get 21. Hence the numerator also will do the same thing, 2x minus 9 times 3. Okay, so now we can simplify or expand the bracket, right? For the first fraction is 7x plus 35 over 21. Then plus, again, expand the second fraction. We get 6x minus 27 over 21. And now we have the same denominator. We can perform the addition here. So 7x plus 6x, we get 13x. 35 minus 27, we get positive 8. So this will be our answer. Okay, now similar for the subtraction here. 3x minus 1 over 9 minus 2x minus 7 over 12. So we have the 9 and 12 as the denominator. The LCM of 9 and 12 is 36 here. So we don't have to multiply these two denominator together like what we did for the first example here. So for the first fraction, 9 we multiply by 4, we'll get 36. So we have to multiply by 4 for the numerator as well. Then we look at the second fraction, so minus here. Right after that, 12 times the 3, we will get 36 here. Hence, the numerator also we need to multiply by 3 here. After that, we expand the bracket, we have 12x minus 4 and over 36. Then minus expand the bracket here, we will have 6x minus 21 over 36. Now, we can see that both fractions we have the same denominator. They move on to perform the subtraction, but for this case you have to be careful here, right? Because as you can see, the second fraction, this is positive, this is negative. When we want to minus, so 12x minus 4, we have to put a bracket here, minus 6x minus 21 over 36. Then we expand the bracket here. We will have 12x minus 4 minus 6x plus 21 over 36. And 12x minus 6x, we will get 6x, negative 4 plus 21, we will get positive 17 that over 36. So this will be our answer. The second type of algebraic fraction is denominators with algebraic expressions. So here's the first example, 2x minus 1 over 3x plus 5x plus 4 over x. As you can see from here, the LCM of 3x and x is 3x. So the first fraction we don't have to do anything because the denominator is already in 3x. But for the second fraction, we have to multiply by 3, right, for both the numerator and the denominator, so that it will become 15x plus 12 over 3x. And now from here, both fractions have the same denominator, so we can start to perform the addition here. So 2x plus 15x, we have 17x, negative 1 plus 12, we have positive 11. So the answer will be 17x plus 11 over 3x. So here's a second example here with the denominator with algebraic expressions. So we have 7x plus 3 over 3x minus 1 minus x plus 5 over x plus 2. As you can see for this example compared to the previous example here, okay, this example and this example, you can see that the denominator we have 2 terms. Here also we have 2 terms, but from here we have only 1 term. Okay, so the process will be a little bit more complicated than the first one, right? So what we have to do is, from here, the LCM of 3x minus 1 and x plus 2 will be 3x minus 1 times x plus 2. So we just multiply these two expressions together. Okay, so this is what we get, the 3x minus 1 times x plus 2. For the numerator, the first one is 7x plus 3. We have to multiply with x plus 2. Then minus, because over here, this is minus. Then we have to follow minus here, right? Then x plus 5, this numerator have to multiply with 3x minus 1. Okay, then once we reach here, we have to expand the bracket and simplify. So now from here, 7x times x, we get 7x squared. 7x times 2, we get 14x. 3 times x, we get 3x. 3 times 2, we get 6. The minus, okay, from here you have to be careful. You have to be very clear. You want to expand the bracket first, then you involve with the minus sign here. So what we have to do is we just put a minus, then we start to write the bracket. So bracket x times 3x, we get 3x squared. Then x times negative 1, we get negative x. 5 times 3x, we get positive 15x. Then 5 times negative 1, we get minus 5. Then we close the bracket. Okay, so after that, we can start to simplify, right? So for this one, will be 7x squared. So 14x plus 3x with 17x. Then plus 6. Now I want to first we simplify inside here, right? We will have 3x squared. So minus x plus 15x is positive 14x. Then minus 5. So the next step is to expand this bracket. So this whole thing, we don't do anything. We just copy down. Then we expand the bracket here. All the signs here have to change. Positive become negative, negative become positive. Okay, so this is what we get, negative 3x squared minus 14x plus 5. The next step, of course, they have the same denominator, so we can perform all the addition and subtraction from the numerator here. So 7x squared minus 3x squared, we get 4x squared. 17x minus 14x, we will have positive 3x. 6 plus 5. So we'll get 11. Then this will be our final answer. Now let's see example 5. Simplify each of the following as a single fraction in its simplest form. A. 5 over 7x plus 3 over x squared. B. 5a over 4b minus 2b over 3a. So here's the solution for A. 5 over 7x plus 3 over x squared. So let's look at the denominator. The LCM of 7x and x squared is 7x squared. Hence, for the first fraction, 5 over 7x, we need to multiply by x for both numerator and denominator. Then plus with, for the second fraction, 3 over x squared, we have to multiply by 7 for both the numerator and denominator. So we'll get 5x over 7x squared plus 21 over 7x squared. And now, both fractions have the same denominator, hence the answer will be 5x plus 21 over 7x squared. For B, 5a over 4b minus 2b over 3a. So for 4b and 3a, the LCM for both of them will be 12ab. Hence, for the first fraction, 5 over 4b, we need to multiply 3a for the numerator and denominator. And for the second fraction, minus 2b over 3a, we need to multiply with 4b at the top and the bottom. And we'll get, for the first fraction, is 15a squared over 12ab. Then minus the second fraction, 8b squared over 12ab. Now, both fractions have the same denominator. So we'll get 15a squared minus 8b squared over 12ab. Now let's try this yourself. Simplify each of the following as a single fraction in its simplest form. A. 2 over 5r squared plus 5 over r squared. B. 7 over 4xy minus 2 over 5yz. You can pause the video and try to do it yourself. Alright, so here's the solution for A. 2 over 5r squared plus 5r squared. So the LCM for 5r squared and r squared is 5r squared. Hence, for the first fraction, we don't have to do anything. For the second fraction, we have to multiply by 5 for the top and the bottom. So we get 2 over 5r squared plus 25 over 5r squared. Now, we have the same denominator for both fractions. Hence, we can add the numerator together. We'll have 27 over 5r squared. For B, 7 over 4xy minus 2 over 5yz. So let's check the denominator. The LCM of 4xy and 5yz is 20xyz. Hence, For the first fraction, we have to multiply by 5z at the top and the bottom. Then for the second fraction, we have to multiply by 4x for the top and the bottom. And we'll get 35z over 20xyz minus 8x over 20xyz. Now they have the same denominator, so we combine them together, we'll have 35z minus 8x over 20xyz. So this will be our answer. Now we'll look at example 6 where the denominator of the fraction has more than one term. So simplify the following expressions in the simplest form. A. 3 over x minus 7 plus 2 over 3x plus 5. B. 5 over 4x squared minus 9 minus 7x over 3 minus 2x. C. 5 over 6x squared minus 17x minus 14 minus 3 over 7 minus 2x. And D. 2 over 9x squared minus 30x plus 25 plus 7 over 5 minus 3x. So here's the solution. For A, 3 over x minus 7 plus 2 over 3x plus 5. So we have to multiply the denominator together because this is their LCM. So from the numerator, the 3 have to multiply with 3x plus 5. And another numerator 2 here have to multiply with x minus 7. Now we expand the bracket. We'll have the first bracket is 9x plus 15 and the second bracket is plus 2x minus 14. Okay, so we simplify further. We'll have 11x plus 1 over x minus 7 times 3x plus 5. For B, 5 over 4x squared minus 9 minus 7x over 3 minus 2x. So what we have to do is we can factorize the denominator at the first fraction. 4x squared minus 9 is in the form of a squared minus b squared. Okay, so when we factorize, we'll get 2x plus 3 times 2x minus 3. The rest we don't do anything, we just copy down here. Right, so from here now we compare these two fractions, 2x minus 3 and 3 minus 2x. So this is the mirror. So we have to swap these two and then change the sign here. So it becomes, right, the first fraction we don't do anything, just copy down. And this minus become plus. So 7x over, so switch these two, become 2x minus 3. Okay, then from here, the LCM for these two denominator will be 2x plus 3 times 2x minus 3. So the first fraction we don't do anything, we just copy down. The second fraction we have to multiply with 2x plus 3 at the top and the bottom so that both of the fractions have the same denominator. Okay, so this is what we get. So 5 plus 7 times 2x plus 3, when I expand the bracket, we have 14x plus 21. Then simplify, we'll have 14x plus 26 over 2x plus 3 times 2x minus 3. So this is the answer for B. Solution for C, 5 over 6x squared minus 17x minus 14 minus 3 over 7 minus 2x. So the very first thing we have to do is we have to factorize this denominator. So when we factorize, so 5 we'll use the double bracket method. So first 2x times 3x we'll get 6x squared. Then 7 times 2 we'll get 14. Then I put a negative sign here and positive sign here. Right, I will check. Negative 7 times 3x plus 2 times 2x, I'll get minus 17x. Okay, so 5 we just copy down here, then minus the second fraction. After that, we'll look at these two fractions, 2x minus 7 and 7 minus 2x, they are the mirror. So what I have to do is I have to switch this sign and then swap these two terms here. Okay, so the first fraction, we don't do anything, copy down. So minus become plus, then 3 over 2x minus 7. Okay, and compare these two denominator, we have 2x minus 7, 2x minus 7. So this second fraction, we'll multiply with 3x plus 2 for the top and the bottom. And then expand the bracket here. So 5 plus, so 3 times 3x is 9x. 3 times 2 will get positive 6. Simplify here, we will get 9x plus 11 over 2x minus 7 times 3x plus 2. Alright, solution for D. These two fractions, look at the first fraction. We have to factorize the denominator here. So when we factorize, right, as we can see here, it is in the form of a squared minus 2ab plus b squared. Okay, so that means when we factorize, it will become 2 over 3x minus 5 squared. So this is the second fraction, we don't do anything, just copy down. And we compare these two, right, as you can see, 3x minus 5 and 5 minus 3x, they are mirror again. So what do we need to do? Switch the sign, and these two terms, we swap the position. This is what we get, 2 over 3x minus 5 squared, then plus become minus 7 over 3x minus 5. So this fraction need to multiply with 3x minus 5 at the top and the bottom, so that both of these fractions have the common denominator. Right, then we simplify. 2, then minus 7, expand the bracket here, times 3x, I'll get minus 21x, and minus 7 times negative 5, I'll get negative 35. Okay, so simplify them together, right, we had minus 21x minus 33 over 3x minus 5 squared. So, or if you want, you can factorize, right, because 21x and 33, the common factor is 3. So we have negative 3 bracket 7x plus 11 over 3x minus 5 squared. Now it's your turn to try it yourself here. Simplify the following expressions in the simplest form. A. 7 over 3x minus 1 plus 5 over 4x plus 9. B. 2 over 16x squared minus 25 plus 6x over 5 minus 4x. C. 1 over 15x squared minus x minus 6 minus 2 over 3x minus 2. And D. 4 over 4x squared minus 28x plus 49 plus 3 over 7 minus 2x. You can pause the video and try to do it yourself. Okay, so here's the solution for A. 7 over 3x minus 1 plus 5 over 4x plus 9. So the denominator has to multiply together so that we'll get the common denominator. And for the 7, it has to multiply with 4x plus 9. Then plus 5, it has to multiply with 3x minus 1. Okay, then we expand the bracket. 7 times 4x, we get 28x. 7 times 9, we get 63. Plus 5 times 3, we get 15x. 5 times negative 1, we get minus 5. Alright, when we simplify, 28x plus 15x, we'll have 43x. 63 minus 5, we get 58. So this will be our answer for A. For B, 2 over 16x squared minus 25 plus 6x over 5 minus 4x. So we have to factorize the denominator of the first fraction. We'll get 2 over 4x plus 5 times 4x minus 5 because it is in the form of a squared minus b squared. And the second fraction, we don't do anything, we just copy down 6x over 5 minus 4x. Then from here, we can see that 4x plus 5 minus 4x, they are mirror, so we can switch the sign and the position. We get 2 over 4x plus 5 times 4x minus 5, then minus 6x over 4x minus 5. And the second fraction, we have to multiply with 4x plus 5 for the top and the bottom, so that both of the fractions will have the common denominator. So we'll get 2 plus 24x squared plus 30x over 4x plus 5 times 4x minus 5, or it will be factorized the 2, we have 2 bracket 12x squared plus 15x plus 1 over 4x plus 5 times 4x minus 5. So this is the answer for B. So solution for C, 1 over 15x squared minus x minus 6 minus 2 over 3x plus 2. So the first thing I have to do is I have to factorize 15x squared minus x here. So apply double bracket here, then 3x times 5x, I'll get 15x squared. 2 times 3, I'll get 6. I put a negative and positive here. So now negative 2 times 5x plus 3x times 3, I will get negative x here. Then the rest, the one I write down here, then minus the second bracket here. We don't do anything, just copy down. So from here, we compare these two fractions. The LCM for these two fractions, right, will be 3x minus 2 times 5x plus 3. So it multiply the 5x plus 3 at the top and the bottom for the second fraction that expand. So it become 1 minus, so 2 times 5x become 10x. Negative 2 times 3, I get minus 6. Alright, so the bottom just copy down. Then combine these two, negative 10x. And then 1 minus 6, I'll get negative 5 here. So I can factorize negative 5 because compare these two terms here, the common factor is negative 5 and then bracket 2x plus 1. So over the denominator 3x minus 2 times 5x plus 3. This is the answer for C. Then move on to D, right? So this is the expression given. We look at here, right? The denominator for the first fraction, it is in the form of a squared minus 2ab plus b squared. Alright, the a is 2x, the b is 7. So we can just factorize, becomes 2x minus 7 squared. Okay, the special product case. Then the rest, we don't do anything, just copy down. Now I will compare, right, 2x minus 7 and 7 minus 2x. So these two are the mirror. So switch these two terms and change the sign here. So it becomes 4 over 2x minus 7 squared, then minus 3 over 2x minus 7. So the LCM will be 2x minus 7 squared for these two fractions. So this fraction I have to multiply 2x minus 7 at the top and the bottom. Then becomes an expand here, right? 4, just copy down. So minus 3 times 2x, I'll get negative 6x. Minus 3 times negative 7, I'll get positive 21. So combine them together, we'll get 25 minus 6x over 2x minus 7 squared. So this will be the answer for the D. Now we come to the last part of the lesson, the subject of formula. To explain the concept for this topic, let's consider this. A simple English sentence consists of three components: the subject, followed by the verb, and the predicate. Here are some examples here. My brother plays the basketball. So the subject is my brother, plays is the verb, and the basketball is the predicate. Similarly, my father is the doctor. Alright, so from here, my father is the subject, is the verb, and the doctor is the predicate. Here's a question. Can we swap the subjects and predicates, and the sentences will bring the same meaning? Yes, we can do that. Here's the new sentences. The basketball is played by my brother. The doctor is my father. Okay, so the basketball and the doctor now becomes the subject. Is played by and is are the verb, and my brother and my father, they are the predicates. Alright, so we are not actually learning English here. We talk about mathematics. In mathematics, I would say it is in terms of the language. Mathematical equation, we can treat as the sentence can do the same thing too. So let's look at this simple example. A equals B plus C. So the subject for this equation will be the A. So this equation is read or interpreted as A is, which means equals B plus C. A is the subject, equal sign is the verb, and B plus C is the predicate. So we can also change the subject, where we make B the subject. So now B will become A minus C, or I change C as the subject. So C equals A minus B. So this is how we want to change the subject of a certain formula or certain equation. To change the subject of formula, there are some rules that we need to follow. Here are the rules. Rule number 1, if A equals B plus C, I want to make B the subject. then b equals a minus c. Example, y equals x plus 3, and to make x the subject, it becomes x equals y minus 3. Rule number 2. If a equals b minus c and I want to make b the subject, then b equals a plus c. Here's an example. Y equals x minus 3, then x equals y plus 3. Rule number 3. If a equals b times c, or we can just write as equals bc. To make b the subject, then b equals a divided by c, or we can leave it as fraction equals a over c. Here's an example. Y equals 3x, then x equals y over 3. The next rule, rule number 4, if a equals b divided by c, or in fraction form, b over c, then b equals a times c. So, or we can just write it as equals ac. Here's an example. Y equals x over 3, then x equals 3y. Rule number 5. If a equals b squared, and you have to be careful with this rule. So b will be plus minus square root of a. Don't forget with the plus minus sign. Here's an example. Y equals x squared, then x equals plus minus square root of y. Rule number 6. If a equals square root of b, then b equals a squared. Here's an example. If y equals square root of x, then x equals y squared. Also, from rule number 3 and rule number 4, we can combine them together. Like if a equals a fraction m over n multiplied with a b, then b equals a times n over m. Here's an example. Y equals 5 over 7x, then x equals 7 over 5y. As you can see from here, the fraction, when we change to another side, it becomes reciprocal. So remember all these rules. Now, let's look at example 7. Given the formula a equals v minus u over t, express u as the subject of formula. Hence, find the value of u when a equals 2, v equals 10, and t equals 3. So here's the solution. Given the formula a equals v minus u over t, so I move the t to the left hand side, it becomes at equals v minus u. Then I move the u to the left hand side, at plus u equals v. And I move the at to the right hand side, so u equals v minus at. So I have made u the subject of the formula. Next, when a equals 2, v equals 10, and t equals 3, we just need to substitute all these values into the equation. So the u equals now 10 minus 2 times 3. And the value will be 4. Alright, now you can try this example yourself. Given the volume of a solid can be calculated with the formula v equals 2 over 3 bracket h plus 5l. Express h as the subject of formula, and hence find the value of h when v equals 120 and l equals 4. You can pause the video and try to do it yourself. Okay, so here's the solution. Given this formula, v equals 2 over 3 h plus 5l, then I want to make the h the subject, so the h is here. So the first step I have to do is, I'll move this fraction to another side, so it becomes reciprocal. H plus 5l equals 3v over 2. Then I move the l to another side, right? So h plus 5 equals 3v over 2l. Then h will be 3v over 2l minus 5. Next, when v equals 120 and h equals 4, just substitute these values into the equation. So h equals 3 times 120 divided by 2 times 4, then minus 5. Then calculate the value of h will be 40. Now let's look at example 8 here. Given the formula P equals 7Q minus 4R over 3Q plus 5R. Express Q as the subject formula. Okay, as you can see here, the formula now looks slightly more complicated. So the solution is, given this is the formula, so I want to make Q the subject. And from here, as we can see, the Q is at the numerator and also at the denominator of this fraction. So what I have to do is we have to move this denominator to the left-hand side and becomes multiplication. So it will be P times 3Q plus 5R equals 7Q minus 4R. Then I want to expand this bracket. So P times 3Q becomes 3PQ. P times 5R becomes 5PR. So the rest we just copy down, 7Q minus 4R. So once I reach this step, I see that the subject I want to change is this Q, right? It is in this term and also in this term. So I have to move these two terms in one side, and the terms that don't have the Q, I'll move to another side. So I move this 7Q to the left side, 5PR to the right hand side. So I will get 3PQ minus 7Q equals negative 4R, then minus 5PR. Because here is plus, they become minus. So now, as you can see, the Q is at the left hand side for both terms here. What I will do is, I will just take it out. Factorize Q, bracket 3P minus 7. For the right hand side, the common factor is R. I can factorize the R of course with the negative sign here, negative R bracket 4 plus 5P. Then I'll move this bracket to the right hand side, becomes division. So the Q will be equals negative R bracket 4 plus 5P over 3P minus 7. So this will be the answer. Okay, so you can try this example yourself here, right? Given the formula y equals 3x squared plus 8z plus 9x squared plus 7z. So express x as the subject of formula. You can pause the video and try to do it yourself. Alright, so the solution here is, given this formula, y equals 3x squared plus 8z over 9x squared plus 7z. The subject I want to change, right, is the x here. So as you can see, it is at the top and the bottom. I have a square here also, so I need to be careful when to change. So again, move this denominator to the left hand side, becomes multiply y bracket 9x squared plus 7z, then equals 3x squared plus 8z. The next step, I will expand this bracket. I will have 9x squared y plus 7yz. So this the expression at the right side, we just copy down. We don't do anything. Now look at these two terms, right? We have the x squared. Oh no, we have the x squared is the left side and the x squared is the right side. We don't want to group them to one side, but the 7yz, we don't have the x term. I have to move it to the right side. So it becomes 9x squared y minus 3x squared equals 8z minus 7yz. And now the x squared will be the common factor for these two terms. The z will be the common factor for these two terms. So factorize them out. I'll have, oh yeah, including that 3. So it's 3x squared times 3y minus 1 equals z times 8 minus 7y. Okay, so now just make y square the subject. Everything move to the right side as the x squared. I will get z times 8 minus 7y over 3 times 3y minus 1. So I don't want the square. That means I have the square root for both sides, and it becomes x squared, and the x equals plus minus square root of z times x minus 7y over 3 times 3y minus 1. So do you get the answer correctly? Let's see one more example. Example 9. Given the formula f equals 1 over 2 pi square root of k over m plus l, express m as the subject of formula. So here's the solution given this formula, and I want to make m the subject, so the m is here. The first thing I want to do is I want to move this 2 pi to the left hand side. So it becomes 2 pi f equals square root of KOM plus 1. Alright, because the 1 here actually is here, we don't write the 1. Then as I can see, I have square root here. I want to remove the square root, I have to square both sides. Then this square root will be removed. When I square both sides, the 2 pi f, all these three terms here I have to square. I will get 4 pi square f square. And the right side only left with KOM plus L. Okay, the M is still here. So we have plus L. I have to move this plus L to another side, becomes minus L. So it's 4 pi square f square minus L. So we still have K over M. M is still here. So I'll move this to the left hand side and this whole thing to the right hand side. So what will happen? Then M will be equals to K over everything here, 4 pi square f square minus L. So I have made M the subject of this formula. Okay, now let's try this example yourself one more time. Given the formula s square equals 1 over n bracket x square minus y square. So you have to express y as the subject of formula. You can pause the video and try to do yourself. Okay, now solution. Given this formula s square equals 1 over n x square minus y square. Identify what I want to make the subject of formula, the y is here. So I have to handle this 1 over n first, move this to the left hand side, becomes n s square equals x square minus y square. Alright, so next one, I want to isolate this term y square. I will move to the left hand side and the n s square to the, when I move it to the right hand side, becomes n left hand side, sorry, n s square plus y square equals x square. Then this ns square move to the right hand side, becomes y square equals x square minus ns square. Okay, I don't want the square here, I have to square root both sides. So y equals plus minus square root x square minus ns square. So this will be the answer for this example. Do you get the answer correctly?